I appreciate baby steps. I appreciate it.
Yeah.
I remember.
100%.
All right, Lewis dot diagrams. I don't remember what the dude's first name was, but he had a lot. He actually has. Do you remember back when we were doing acids and bases in regular chem? And there's like the Bronsted-Lowry acids and bases, and there's different definitions of what a base is or an acid is. There's also a Lewis acid and base, but we don't get into that in AP Chem. That's off in the distance for you. You're gonna be thankful. Okay, but he comes up several times in the world of chemistry. So if you go on to take more advanced chem, you'll be seeing him even more. All right, Lewis structure. We are going to represent atoms. They're going to connect to a molecule. The Lewis structure, you're essentially looking at your valence electrons. You're ignoring all the inner electrons and just looking at valence. Remember how to figure out valence electrons. S column, first column is 1, second column is 2 valence electrons. Skip the D block, it's just a hot mess. Then we go 3, 4, 5, 6, 7, and finally 8 through the P block. Remember all that? How to count how many you got? All right. Typically, when we're doing Lewis dot structures, they're going to be nonmetals anyway. So it's all going to be on this, on the P block side of the periodic table anyway, with maybe hydrogen thrown in. But remember, hydrogen is a nonmetal, so technically he's still available for use. We typically will count how many electrons we've got, and we either have a line or a pair of dots between the atoms. Those are going to represent your shared electrons. So if you are counting these and you're doing your Lewis dot structures and you're going like hydrogen and you want to attach it to a chlorine, okay, you could do 2 dots, but typically it's done with a line. It's faster. Okay, so a line counts for 2 dots. Okay, if we have 2 lines between them, that means that we have a double bond. So something like carbon, you might see, a structure with carbon here where you've got like a hydrogen up here with a single bond. So you might see a structure like that. This is a double bond. It's going to have 4 electrons that are holding that together. Then you can have a triple bond, like between nitrogens. Okay, so that would be 6 electrons in a triple bond. Pair of electrons on a single atom is called a lone pair of electrons, and I have that represented right here and here. Okay. When you're building these, you want to make sure that everything except hydrogen only needs 2, but everything except hydrogen has 8 electrons on it. So when you're done, go back and count. 2, 4, 6, 8. 2, 4, 6, 8. Here, I didn't draw these on. The chlorine would look like that. And when they ask you for a Lewis dot structure, you have to put all of these dots around here. Okay?
So that applies to every element except for hydrogen.
Well, every non-metal. For the most part, there are some exceptions, which we will get into in the coming days. Okay, so there are some exceptions. So if you start looking some of these things up, okay, if you remember correctly from regular chem, and I'll go through this as we move on, but there are things that can have expanded octets. Okay, so if you're dusting off a few cobwebs, expanded octets are in period 3 and down. So they can hold more than 8 electrons. And then you have one that has a reduced octet. Do you remember which one that is? It's happy with 6. It's boron. Okay. And we'll get into those. I don't know if I get into those today or tomorrow. It's all of this kind of meshes together for me. So I have to see. All right. Any questions on these so far? Remember all of this jazz? Okay. Some of this is just going to have to be practiced. Like you will literally have to draw these things over and over and over again. And then at some point along your journey, it'll just click and you'll be able to just draw them and not have a problem. Okay. But some of you, it's going to take a little longer to get to that point, but you'll get there if you follow my methods. Stick with me. Don't give up on me. All right. So you're going to determine the total number of valence electrons in the atom. And by group A here, what they're talking about is your S and P blocks. Those are called your group A elements. Okay. So we typically will only be using group A because these are covalently bonded, and those are your nonmetals, and they're in your P block except for hydrogen. Okay. Draw a skeleton structure. So place a single bond between the atoms at a starting point. The atom that needs to make the most bonds to fill its octet is usually placed in the center. The other thing that you can know about this is typically the most or the least electronegative element will be in the centers. And remember how your formulas are set up. They start with the least electronegative and move across from there. So usually the first one listed in that string is going to go in the middle. Okay. Then you're going to finish these out trying to share electrons. And like I said, the least electronegative element is going to be in the center. Hydrogen and halogens, almost all halogens and always hydrogen has to be on the end. Okay. If you think about it, hydrogen has 1 electron. It needs how many to be happy? 2. Can it take any more in? Hydrogen can't take any more in. So once it's bonded, like with a carbon over here, once it's gotten bonded with a carbon, it's got those 2 electrons. It can't have anything else coming off of it. It always has to be on the end. Fluorine, for the same reason. Fluorine can only take 1 more in from another element. It is in period 2. It cannot expand its octet. So once it's got that extra thing bonded from another atom, it's done. So it always has to be on the end. All right. Then, continue. Remember your third period, they can expand their octet. We talked about that in regular chem back in the day. Okay. And then you're going to share. That's when the central atom has more than it can hold. We'll get into that in another few slides or tomorrow. I don't remember when. Place the remaining electrons as lone pairs so that you can fill as many octets as possible. Starting with the most electronegative and working your way in. And then if you run out of electrons, that's when you've got a double and triple bond. It's like solving a puzzle. So if you like solving puzzles, this is your game. But like I said, you're just going to have to practice. The thing will change slides when I don't want it to, but when I want it to, it won't. It's frustrating. All right. So here are our steps. You're going to count your valence electrons. So what column is it in? Carbon, 1, 2, skip a few, 3, 4. That's where we got the 4 here. Okay. Hydrogen, you have 4 hydrogens, 3, 4. And each one of them has 1 electron. It's in the first column. Oxygen, you have 1 of those It has 6. Count the columns. And then we total those up. So 4 plus 4 plus 6 is 14. This is how many we've got to work with. You cannot have any more electrons than that. That's it. So we know to put carbon in the middle, right? Because carbon is listed first. So that's your little hint there, okay? Now, notice this OH here. You see that right there? That's an indicator. When you see a formula written like that, that means that there's going to be an O and there's going to be an H attached to that oxygen. So go ahead and draw your O coming off of here and then draw a hydrogen coming off of it. Okay? And really, it has to work that way because you can't take this hydrogen here and attach it to here. Why? Right, this hydrogen can't have 4 electrons, so that doesn't work. You couldn't have the hydrogen here and the oxygen here because, again, that hydrogen would have too many. So this is realistically the only way that you're going to be able to get this to work anyway. Okay? So then you go ahead and you're placing your electrons. So you're going to connect all of these up with lines and count in your head. 2, 4, 6, 8, 10. Okay, I had 14 to work with. That means that I have 4 left over. I'm going to go around and find my outer atoms, and I'm going to try to get them to be an octet. So right now, as oxygen stands, it only has here 4 electrons. It needs 8. So I'm going to place lone pairs on these on the oxygen, and that's going to take me up to my 14, and I'm going to be good. Make sense? Remember how to do these? This is just this whole chapter. I pretty much taught this whole chapter to you. If you took Honors Chem, this is just a revamp of Honors Chem. I don't really add anything extra in this unit. That's why we go through it in like 2 weeks. There are no labs for this one. The next chapter, there's like 3 labs, 2 or 3. So I catch back up with you there. Okay?
We're reading this next week as well.
Yep.
Okay.
Next week is pretty much just practice. Okay?
Don't we have a weird schedule next week?
Next week, the schedule, Monday and Tuesday are regular days. So those 2 days are normal next week. Then Wednesday is just advisory. So there's nothing weird there. But Thursday is going to be 37-minute classes.
Why?
Because in your advisory, if you are a freshman, sophomore, or junior, you're going to be going to your advisory again on Thursday, and you are going to be taking your pre-ACT math. It's called Mastery Prep. Seniors, they're going to have you guys go, I think, in the gym, and you're doing stuff about graduation and like transcripts and all kinds of senior-y stuff. Yes, dear.
So like make that up if we miss it?
Yep. They will pull you. So do not skip. Yep.
Don't they have on like Monday they take the other
Okay,
sections
so
of each
Monday,
class?
Tuesday, or Wednesday of next week, if you are not a senior in here, you will be taking Mastery Prep. For me, I think I have it scheduled for Tuesday in here, if I'm not mistaken. So yeah, and then seniors, it's just a study home.
Why did you write an R for Thursday?
Because it's different from Tuesday.
Why didn't you just write TH?
Because this is the way we always did it in college when they sent out schedules and stuff. And so Thursday's an R.
Is Friday normal too?
Friday, you don't come to school next week.
Oh yay me! I mean, still
You don't have a Friday next week. No.
Don't we have a game?
I'm sure you do have a football game of some sort, but I don't really
Oh my
keep
gosh,
track of
is
that.
in my planner. That is
Sorry,
so
Lennon.
Exciting. Oh man, I get to go to the
29th, you do not have school. We have professional development.
Well, that's exciting for you, Lippy.
Oh,
Happy Friday.
thank you. Well, this year we have to go for the morning, and then the afternoon we can use our earned release time. So I'll take the afternoon off. So that'll be kind of nice. So I'll take it.
You only gotta wake up early.
Well, for me, that's actually I come in late those days because normally I get here so early, and so on PD days I just get here at 8 o'clock and do my thing and go home. So. All right, let's get back to this guy. Carbon is 4. Hydrogen, we have 2, and then we have we have 1 electron. Oxygen, we have 1 of those, and it has 6 electrons. So I'm going to add those up. I get 12. I'm going to put my carbon in the center here. I'm going to attach my other atoms to it, and then I'm going to count. I've got 6 electrons at this point. Okay. Then I'm going to go and I'm going to try to make oxygen happy. So if I make oxygen happy, 2, 4, 6, 8, 10, 12, my problem is that carbon is not happy. It needs to have 8 electrons. So what I'm going to do is I'm going to pull this lone pair of electrons and I'm going to bring it into here. And I'm going to make a double bond. And now if I do my count, hydrogen has 2, carbon has 2, 4, 6, 8, and oxygen has 2, 4, 6, 8. So everything's good. Complete my octets. Yay or nay?
Okay.
Oh, here is our expanded octets.
I know.
I knew we got into them at some point. So we do have some exceptions. If you recall, we have periods, nonmetals, period 3 and on, have empty D subshells. Okay. So remember, with these, that whole D subshell is empty. So we can start to fill that with some electrons and make bonds. And this is how, if you remember back at the very beginning here, I said hydrogens and most of the time halogens. Well, your halogens that are chlorine and down, they can expand their octets. So that's why I didn't say always. I said hydrogen and fluorine are always like that because fluorine can't expand. It doesn't have a D subshell. But the rest of them do. And so because of that, you can expand their octets. All right. So here we have sulfur and we have fluorine. Sulfur is 6. Fluorine is 42. So that gives us a total of 48 electrons. And I'm going to put all 6 around this sulfur. And I'm going to then, sulfur is going to have more than 8 electrons around it. It has 2, 4, 6, 8, 10, 12 electrons. And that's okay because it can expand. It can take in more. Make sense? Everybody cool with that? You remember those? Okay. All right. Coordinate covalent bonds then. That's where if you... Oh, gosh darn thing. I just, it would just be nice if everything worked.
Yeah, that's not how technology works, Slippy.
No, apparently not. Okay, let's get this guy. See if we can scunch him out of the way. There we go. So remember, boron can be an incomplete octet. Okay, so we talked about that, how boron is happy here. It can be kind of satisfied with 6 electrons. It's an exception. Because why would everything just be, perfect? So that's going to be happy with that. Coordinate covalent bonds, then, that is where one atom is bringing all the electrons to the party, is sharing everything. Okay, so that's how we can get this whole thing to look like this. So this, that if we bring that in, it's going to look like this. And everything will be satisfied. It's just oxygen is contributing both electrons to that bond. as opposed to carbon, because carbon only had 4 electrons. Okay, and those are called CC bonds, coordinate covalent bonds. You don't really need to know the lingo for it. You just need to know that it's okay for oxygen to do that. Sir?
Are we gonna have to draw like the expanded octet?
Quite potentially, yes.
How do we know if they can be expanded or not?
If it's in period 3 and down, they can expand. So for your non-metals, that's going to be silicon, phosphorus, sulfur, chlorine, arsenic, selenium, bromine, tellurium, iodine, and astatine or AT, whatever that is. So all of those can expand because they've got D subshells. Again, it's practice, honestly. So what's going to go in the middle?
Carbon.
2 carbons, yep. So I know I'm going to have a carbon here and here. I need to count my electrons. I should have done that before. So this is going to be 2 times 4 is 8. 3 times 1 is 3. And then chlorine is 7. So this is a total of 18 electrons. Did I lose anybody with my math there? Sir?
Can you go over that again a little?
So carbon is 4. 4 times 2 is 8. Hydrogen is 1, and I have 3 of them. So it's going to give me 3 electrons. And then chlorine is 1, and it has 7 electrons. So add it up, 18. Good? Okay. All right. So we have our carbon here. And we are then going to try to figure out how to get everything around these carbons and hydrogens, or our hydrogens placed and our chlorines placed and everything. So I've got my carbons here. I'm going to put my hydrogens. I got 3 hydrogens. I'm just going to put them here, here, and here. I don't like that. Let's try it again. Chase won't like that either. Right, that's better. I call them out. All right. Then I need to get my chlorine on there. So I'm going to put my chlorine over here. And I'm going to go through and I'm going to count how many electrons I've got placed so far. So 2, 4, 6, 8, 10, 12, 14, 16. Did I count right? 2, 4, 6, 8, 10, 12, 14, 16. I'm missing 2 here. I think 2, 4, 6, 8, 10, 12, 14, 16, 18. That doesn't work. What I've got down on my answer sheet doesn't work.
Doesn't that second carbon need 8 electrons?
Yeah.
Right now she's only got 4.
Right, but I can't. Oh, so
You can move. Can't you move a hydrogen to the second carbon and make a double bond between the 2 C's?
I could move. No, I can't do that. Okay, what, Maddie?
Can you move the?
Move this guy here
Yeah, and then make a double bond.
and then do a double bond there. Yeah, I think that works. Yeah. So is that 18? 2, 4, 6, 8, 10, 12, 14, 16, 18. 2, 4, 6, 8. 2, 4, 6, 8. Yep, we're good.
Are these always going to be like, do all of them always have to have 8, or sometimes can they be like?
Everything needs 8 electrons except hydrogen. Hydrogen needs 2.
Okay. Yeah, I get that.
And you can sometimes expand your octets and make them bigger. But carbon, you can't expand an octet. Why?
It's not in 3.
Right, it's not in the third period, it's only in second. So carbon cannot expand. Okay, I need to fix that. There we go. Okay. So you got some we-dos here. So take a minute or two and see if you can draw those. Work with your seat, buddy. We do need to talk about, though, this guy right here before you get started. We need to talk about him. How is he different from the rest of these?
It's going to be expanded. Oh, wait, no, not that one. Thought we were talking about another one.
Yep. This has a negative charge associated with it. So instead of this having 6, 7 electrons, it's going to have 8. Yep. So you're going to have 8 electrons here because you've got 6 and 1. And then this negative here is going to give you 1 more. And when you draw this, you should draw it in square brackets. And you're going to indicate that extra electron as a charge outside. So your drawing should be within these square brackets. And I'll give you a minute or two to draw those, and then I'll start throwing a few answers up on the board, and you can check your work. But first, is there 2 pages to that, Abby, or just 1? There's 2. You got all those done too. Look at you with your pretty colors. right, you ready for some answers? All right. So I had this guy. I had my carbons in the middle. And my 2 hydrogens off to the end. I had 8 and 2 is 10 electrons. So I want to make sure after I've got this drawn that I have 10 electrons. 2, 4, 6, 8, 10. Both hydrogens have 2 electrons each, and each carbon has 8 electrons. So good there? All right. I have my oxygen, and I'm going to connect it to my hydrogen. I have 2 electrons here. Hydrogen's good. My oxygen needs 8, and I had 6 electrons to spare. So now I have 2, 4, 6, 8 electrons around oxygen. Remember, you need the square brackets with the charge so that you can indicate that that charge exists on that polyatomic. This is called a polyatomic ion. Remember those guys? They were on the back side of your periodic table last year. Notice they're not on the back side of your periodic table anymore. Welcome to AP Chem. All right, I got my carbon here. I'm going to connect my carbon and I'm going to connect my fluorines. I know my fluorines have to be on the end. They cannot connect to anything else. Ever. Ever. And then I'm going to pull my sulfur out here. Okay. I need to do my count. I've got 4 carbons. I've got 14, because 7 times 2 is 14. And then my sulfur is going to be 6. So that's 24 electrons that I need to place. So I'm going to go around. I'm going to go ahead and place those around my fluorines. So right now I have 6 electrons, 8, 10, 12, 14, 16, 18. So 2, 4, 6, 8, 10, 12, 14, 16, 18. I still have how many to go? 6. Okay. So I'm going to go and put 2, 4, 6. So I've used up all my electrons. What is my problem?
Carbon doesn't have 8 electrons.
All right, carbon doesn't have 8. I can't bring in from fluorine because remember it can't have double bonds. It can't expand its octet, so no double bonds. But sulfur can have double bonds. So I'm going to take these 2 and I'm going to bring it in and make a double bond. Could you have drawn this with the sulfur up here? And this, yep. Could you have drawn it with the sulfur? Yeah, you can change this around however you want it to kind of go around. So your sulfur might be, here, and your fluorine might be here. It's fine. It's not a big deal. I just try to balance things out. So. All right. Remember, boron, it has 3 electrons that it's bringing to the party. Chlorine is 7 times 3, which is 21. So I have 24 electrons here. My boron is going to go in the middle. And I'm going to have my chlorines coming off. Okay. Oh, I thought that was my coffee. It's been a rough couple weeks with liquids in my room. All right. So I've got my chlorine. I've got 2, 4, 6. This makes 8, 10, 12, 14, 16, 18, 20, 22, 24. Now, if this boron was carbon, would I have a problem? Yeah, but it's not. Remember, boron can have that reduced octet. It's satisfied with 6 electrons. So we are done. Sulfur is 6. Fluorine is 6 times 7, which is 42, last count. And then that gives me a total of 48 electrons. Sulfur's in the middle. Fluorine can never be in the middle. So sulfur's in the middle. And I'm going to draw my 6 fluorines coming off of there. sulfur can expand its octet. It can let more in.
Mm-hmm.
So we can have 12 electrons around it and be fine. So then I'm going to do, so right now I've got 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40, 42, 44, 46, 48. And that is your We Do Lewis structures. Tomorrow we will talk about something called resonance and something called formal charge. So today's homework, you might end up with slightly different drawn structures than I have. Tomorrow you'll find out why mine are right and yours are wrong, even though you think yours are right tonight based on Lewis structures, because it all comes down to this concept of formal charge. Okay? And that is should minus has, if you remember from last year. If you don't, bring your A game tomorrow. It's not bad. It's really not bad. The way I teach it. Now, there's other ways to teach it, and those are a little bit